good evening, and welcome. If you are hearing this, it is likely that the day, with all of its demands and its details, has finally begun to recede. The light outside your window has softened perhaps, or vanished altogether, replaced by the cool, artificial glow of a street lamp or the distant, silver light of the moon. The world's volume is turning down. The conversations, the traffic, the machinery of the day-to-day, all of it is quieting to a low and distant hum, leaving a space of stillness in its wake. In this space, there is nothing that needs to be done. There is no problem that requires an immediate solution, no argument to be won, no task to be completed. The long list of obligations can be set aside, just for a little while, left to wait for the return of the sun. For this moment, here and now, there is only the simple act of being. There is the gentle weight of your body, supported completely by the surface beneath you. There is the quiet, automatic rhythm of your own breath. And there is the freedom that comes with this stillness, the freedom to let your mind wander, to allow your curiosity to drift without a specific destination or purpose. Tonight, our purpose is not to build a case, to present a startling discovery, or to convince you of a new and radical truth. We are not here to debate. Instead, we are simply going to spend some time together with a question. We will hold it as you might hold a very old object, something found buried in the earth, a piece of sea glass worn smooth by the ocean, or a fragment of pottery whose original shape can only be guessed at. We will turn it over in our minds, feeling its weight, tracing its edges, wondering about the immense journey it has taken to arrive in this moment, without any pressure to give it a definitive name or function. Our curiosity for this evening will not be a sharp, focused beam of light, cutting through the darkness to find an answer. It will be a soft, ambient glow, like candlelight, illuminating just enough of the space around us to make out the shapes of things, inviting a sense of wonder rather than a demand for explanation. It is in this spirit of slow, patient, and unhurried exploration that we can begin. So, let us, for a while, loosen our grip on the solid and settled world. Let's allow our thoughts to drift away from the firm shoreline of established facts and accepted histories and float out into the quiet, open waters of possibility. We spend so much of our lives learning the story of our world, a magnificent and intricate narrative pieced together over centuries. It is a story assembled from the scattered evidence of fossilized bones, from the silent language of rock layers, from the faint, ancient light of distant stars, and from the mathematical elegance of physical laws. It tells of a planet coalescing from a disk of dust and gas, of continents drifting like great slow rafts upon a sea of molten rock, of mountains rising in majestic geological time and being ground back down to sand, of life emerging from the primordial oceans and reaching tentatively at first, and then with explosive diversity, for the land and the sky. We are taught that this story is the truth, a masterpiece of scientific inquiry, painstakingly constructed and rigorously tested. And it is, without question, a breathtaking and powerful account of our origins. But tonight, let us engage in a different kind of thought experiment, one that does not seek to dismantle that story, but to look beneath it, to gently tap on its foundations and listen for the echoes. Let's ask a question that feels less like a challenge and more like a whisper in a vast, empty library. What if the grand book of Earth's history, the one from which we have all been reading, is not the original manuscript? What if it is instead a meticulous but incomplete revision, a later edition from which entire sections, entire volumes even, were not just lost but systematically removed, not through any conscious act of censorship, but by the slow, impersonal and relentless processes of time and geology itself? What if the planet's deepest truths are not written in the rock layers that we can see but are contained within the immense, silent gaps between them? gaps that represent not merely missing pages, but entire libraries of lost information, telling the stories of worlds, of life, of planetary states so profoundly ancient and alien that our entire known history is but a brief epilogue to their existence. What would it mean if the original history of this planet was erased quietly, methodically, and almost completely by the very systems that are responsible for keeping it alive? And what if the story we know now, the one we tell ourselves, was written in good faith on top of those vast erasures, a narrative constructed from the few surviving fragments, beautiful and compelling, but fundamentally, cosmically incomplete? Let's just wonder about that together for a little while. This is not a path to paranoia, but to perspective. It is an invitation to humility. The question is a tool to help us look at our world with a renewed sense of awe, not just for the intricate web of knowledge we have woven, but for the sheer, humbling scale of what might be forever beyond our grasp. It reframes our planet not as a static archive of facts waiting to be read, but as a dynamic, living system that is constantly editing, revising, and overwriting its own autobiography. Some of these edits are small and local, like a river carving a new channel to the sea. Others are almost incomprehensibly vast, like the entirety of an ocean floor, with all its mountains and trenches and layers of sediment being slowly but inexorably pulled back down into the Earth's fiery mantle, its every fossil and feature melted and remixed into the planet's deep, undifferentiated memory. This idea does not make our world a less wondrous place. It makes it infinitely more mysterious. It suggests that beneath the familiar landscapes and the established timelines, there could be the ghosts of other histories, other experiments in being, whose records were ground to dust, dissolved in water, or vaporized by heat, and then recycled by the patient, powerful and entirely in different hands of planetary geology. The mountains we see might be the fourth or fifth generation to rise in that exact spot. The oceans may be filled with water that has participated in cycles of life we cannot even conceive of. The very ground beneath us, the soil, the rock, the continental plates, could be a composite of forgotten worlds. Tonight we will simply explore that possibility. We will not be searching for evidence of a secret, advanced civilization or a dramatic, conspiratorial cover-up. The forces that interest us tonight are quieter, grander, and far more powerful than any single culture or being. They are the forces of geology, of deep time, of planetary physics, the silent, unseen authors and editors of our world's story. We will simply trace the edges of what is known and peer, with respect and wonder, into the profound mystery of what is missing. There is no agenda here other than to cultivate a sense of peace in the face of the immense, and to find a strange and quiet comfort in the idea that our world is deeper, older, and perhaps more profoundly secret than we will ever fully comprehend. And so, as you settle more deeply into your own quiet space, as the rhythm of your breathing finds its own slow and steady cadence, let this question be a gentle point of departure. Let it be a key that unlocks a door, not to a room full of answers, but to a vast, open field under a sky filled with stars we have not yet named. What if the history we know is just the surface layer, the most recent draft, written on a palimpsest of unimaginable age? What if the real story of Earth was not just lost, but actively, systematically, and completely erased? And what story might be told by the silence that remains? Tonight, as we embark on this quiet and expansive exploration, it is important that we establish a few gentle rules for our journey. Think of them not as restrictive laws, but as guardrails on a winding, scenic road at night. They are not there to limit the breathtaking view, but to provide a sense of safety and calm, allowing us to travel with confidence and peace of mind. Our primary purpose here is not to arrive at a final destination, to plant a flag of certainty on some newly discovered peak of knowledge. It is simply to travel thoughtfully, to observe the landscape of a question, to appreciate its contours, its shadows, and its light, without any compulsion to conquer or possess it. The first and most foundational of these guardrails is this: we are here to practice the art of inquiry, not to demand the comfort of certainty. The world we live in often conditions us to seek immediate answers, to resolve ambiguity and doubt as quickly as possible. We are taught to see a question as a problem to be solved, a state of not knowing that must be swiftly vanquished. But tonight, we will approach questions differently. We will treat them as spaces to inhabit, not as puzzles to be completed. We will approach the idea of a rewritten planetary history not as a thesis to be proven or disproven, but as a lens. It is a tool for seeing, a way of looking at the world that might bend the light in interesting ways, revealing patterns and possibilities we had not noticed before. And throughout our journey, we will always remember that it is just that, a lens, a thought experiment, and not a declaration of absolute truth. We will hold our ideas lightly with an open hand, ready to let them go if they no longer serve our sense of wonder. To maintain this gentle posture, we will rely on the concept of provisional models. In science and philosophy, a model is simply a way of thinking about how something works. It's a simplified representation of a complex reality, a map that helps us navigate a territory. The weather forecast with its charts and probabilities is a model. The familiar classroom diagram of an atom with electrons orbiting a nucleus is a model. The timeline of Earth's history with its named eons and epochs is a model. All models are useful, but no model is perfect or permanent. They are all, by their very nature, provisional, subject to revision, refinement, or complete replacement as new information comes to light. In the 19th century, the great physicist Lord Kelvin, a giant of his time, created a sophisticated model to calculate the Earth's age. He treated the planet as a once molten sphere that had been cooling ever since its formation. Based on the known laws of thermodynamics, his calculations suggested the Earth was between 20 and 40 million years old, and certainly no more than 100 million. It was a brilliant model built on the best physics of the day, but it was also profoundly wrong. Kelvin's model had a fatal blind spot. It could not account for a source of heat that was then entirely unknown to science, the heat generated by radioactive decay within the Earth's rocks. When radioactivity was discovered at the turn of the 20th century, it became clear that the Earth had its own internal furnace, which dramatically extended its cooling time. Kelvin's model had to be discarded, and a new one, based on radiometric dating, eventually gave us our current estimate of about 54 billion years. This story is not a failure of science. It is a perfect illustration of its greatest strength. It shows that our understanding is designed to evolve, to correct itself, to grow. So tonight, when we talk about a history that has been erased, we are simply constructing another provisional model. We are asking, what if we look at the world through this framework for a little while? What does it help us see? What new questions does it allow us to ask? And we will do so without ever needing to claim that this model is the true one. It is a way of thinking for a time. Our scope will be deliberately wide, and our language intentionally soft. We will avoid the hard, sharp edges of absolutism. You will hear words like perhaps, might, could, it seems, and tends to. This is not a sign of intellectual weakness or evasion, but a conscious commitment to intellectual honesty. When we are dealing with time scales that dwarf human comprehension and with processes that operate on a planetary scale over billions of years, humility is the only sane and appropriate stance. We cannot stand in our fleeting present and speak with unearned arrogance about what did or did not happen 1 billion or 3 billion years ago. The geologic record, as we will come to see, is profoundly, fundamentally, almost violently incomplete. It is less like a complete, leather-bound encyclopedia and more like a handful of singed, water-damaged pages rescued from a library that has been ravaged by storms and fires for eons. We will honor the incredible work of those who have painstakingly pieced together a coherent story from those surviving pages, while also holding a deep and abiding respect for the vast, silent mystery of the pages that are gone forever. We are not presenting an alternative history. We are exploring the nature of historical erasure itself, using the earth as our grand and mysterious canvas. The method of our inquiry will be gentle and associative. We will move from the small and familiar to the vast and ancient. We will begin by exploring patterns of forgetting and erasure that we can see in our own lives and in human history, and then we will scale them up, using them as analogies to help us imagine the immense geological cycles of the planet. We will draw on the findings of established science, geology, physics, biology, not to build a rigid and unassailable case, but to provide us with the tools, the vocabulary, and the concepts we need to think more clearly and creatively about our question. We will speak of plate tectonics, of subduction, of erosion, of deep time. These are not just technical terms to be memorized. They are the names of the mechanisms by which a planet might forget its own past. They are the verbs of planetary erasure. By understanding the how, we can more deeply appreciate the scale of the what-if. We will also maintain a crucial distinction between patterns and intentions. When we speak of history being rewritten or erased, we are using a metaphor. We are not at any point suggesting that some conscious entity, some planetary intelligence, is deliberately hiding its past. The processes we will discuss are impersonal, automatic, and majestic in their indifference. A tectonic plate, grinding its way beneath a continent and melting back into the mantle at a few centimeters per year, is not trying to hide anything. It is simply obeying the inexorable laws of physics, of heat, pressure, and gravity. But the consequence of that dispassionate physical act is a permanent and total erasure of the record that was written on that plate. This distinction is vital. It keeps our inquiry in the realm of natural philosophy and systems thinking, and far from the heated, anxious territory of conspiracy. We are interested in the planet as a system, a vast, self-regulating and self-editing machine that has been running with unimaginable power for billions of years. So, let these be our guides tonight. A spirit of gentle inquiry, an appreciation for provisional models, a vocabulary of humility, a method of scaling up from the familiar to the immense, and a clear understanding that we are talking about impersonal, natural processes. With these guardrails in place, we create a safe and open space where it is possible to wonder, to speculate, and to feel a sense of profound awe. We are not here to build a new fortress of belief. We are simply here to sit together in the quiet, to look out at the vast, dark ocean of time, and to wonder about the stories that may lie forever silent beneath its waves. Before we journey out into the immense, abstract corridors of deep time, let's first do the opposite. Let's bring our attention all the way in, not just to the room we are in, but to the direct, immediate, and undeniable reality of this present moment. The grandest questions about the cosmos are always asked from a small, quiet, and very specific place, just like this one. So just for a moment, allow yourself to arrive fully where you are. Begin by noticing the air. Feel it as a physical substance. Is it cool on your skin, or is it warm and still? Can you feel a subtle current, a gentle movement from a vent or a window left slightly ajar? The air in this room is a fluid medium, an invisible ocean in which we live. It connects you to everything just outside these walls. It carries the faint, residual sense of the day, the muffled sounds of the world outside, the subtle thermal signatures of the objects around you. This air has weight. It has a history. Its molecules of nitrogen and oxygen have been cycled for eons, breathed in and out by dinosaurs, dissolved in ancient oceans, locked in the blue ice of glaciers, released by the leaves of primeval forests. It is an ancient medium, and right now a part of it is inside you, participating in the chemistry of your own life in this very breath. Now bring your awareness to the points of contact between your body and the world. Feel the specific texture of the fabric against your skin, the smoothness of a sheet, the softness of a blanket, the weave of clothing. Notice the solid, unyielding support of the surface beneath you. It is holding your weight completely, reliably, without any effort on your part. This simple, constant support is a local, personal experience of a planetary force, gravity. It is the persistent, gentle, and inescapable pull of the entire mass of the Earth, all 4.5 billion years of its accumulated matter, reaching up to hold you in place. It is the background hum of our physical existence, so constant that we usually forget it is there. But for this moment, notice it. Feel what it is like to be held by a planet. Think for a moment about the materials that make up the room around you. The wood in the floor, the desk, or the bed frame was once a living tree, a biological machine that spent years, or decades, pulling carbon dioxide from the air and drawing minerals and water from the soil to build its structure. The plaster or drywall in the walls likely contains gypsum, a mineral that crystallized out of vast, evaporating seas millions of years ago. The metal in the lamp beside you, the copper in the wires within the walls, the silicon in the glass of the window, these elements were not made on Earth. They were forged in the thermonuclear hearts of long-dead stars, scattered across the galaxy in supernova explosions, and eventually gathered together by gravity to form our solar system. Your immediate, mundane environment is a museum of transformed materials, a quiet and humble testament to incomprehensible cycles of stellar fusion, planetary formation, geological reinvention, and biological life. Everything around you has a deep and complex backstory. You are living inside a library of materialized history. And then there is your own body, the most intimate environment of all. Feel the gentle, rhythmic motion of your breathing. An inhalation, a pause, an exhalation. This quiet, autonomous pulse is an echo of the planet's oldest rhythms. The ebb and flow of the tides, the waxing and waning of the moon, the cyclical turning of the seasons. Your heartbeat, a steady, faithful drum in the quiet of the room, is powered by intricate electrical signals and chemical reactions that are shared in their basic form by nearly all forms of animal life we know. The water that makes up more than half of your body has been part of a continuous planetary cycle for billions of years. It has flowed in rivers that no longer exist, fallen as rain on continents that have since drifted apart, been held in the cells of countless organisms that came before you. You are, in the most literal and unsentimental sense, a temporary and exquisite arrangement of Earth's materials, animated for a short time by a spark of energy that ultimately comes from the sun. You are not separate from the planet's history. You are an active, breathing, thinking expression of it. For this moment, just rest in that awareness. Let go of the abstract idea of a self that is separate from the world, and just feel what it is like to be a physical part of this reality. The sounds you hear, the air you breathe, the support you feel, these are the points of interface where you and the planet are in constant, intimate conversation. Finally, think for a moment about the weather outside. You don't need to know exactly what it is. Just hold the idea of it in your mind. Whether it is raining or the sky is clear, whether it is windy or perfectly still, the atmosphere beyond your walls is a vast, chaotic, and beautiful system in motion. It is a planetary-scale thermal engine, driven by the immense energy of the sun, constantly working to redistribute heat from the equator to the poles. The intricate patterns of the weather, the swirl of a storm system, the path of the jet stream, are a direct consequence of the planet's size, its rate of spin, the 23.5-degree tilt of its axis, and the specific arrangement of its oceans and continents. The simple, personal feeling of a cool night or a humid evening is your local, sensory experience of this planetary-scale system in action. And the history of that system, the climate, is written in the layered ice of Antarctica and Greenland, and in the fine-grained mud at the bottom of the deepest oceans. Your personal, fleeting experience of tonight's weather is the very tip of an iceberg of immense temporal depth. By grounding ourselves in these simple, tangible, sensory details, the air, the points of contact, the materials in the room, the rhythms of the body, the state of the weather, we accomplish something crucial. We establish our starting point. We place a pin on the map of reality and say, we are here, now. From this grounded, present tense position, we can begin our exploration into the past with a sense of stability and perspective. The mind-bending abstractions of geology and the almost spiritual vertigo of deep time can feel untethering, but they always connect back in an unbroken chain to the physical reality of the here and now. The ancient rock layers in a distant canyon are made of the same fundamental particles as the floor beneath you. The ancient processes that erased 1 billion years of history are still at work, subtly and slowly, in the chemical weathering of the concrete outside and the settling of dust in the corners of your room. The grand planetary story is not just something that happened long ago and far away. It is happening now, and you are inside of it. So let this be our anchor, the simple, quiet, undeniable fact of your own presence in this room, on this night, held by this planet. From this point of stillness, we can now turn our gaze outward and backward into the deep and silent abyss of time, to ask whether the Earth's real history has been erased and rewritten might, at first, sound like a dramatic, almost sensationalist proposition. It can conjure images of cosmic conspiracies or hidden truths designed to provoke a sense of shock or alarm, but the real stakes of this question are, in fact, the opposite of hype. They are quiet, subtle, and profound, and they have far more to do with our inner landscape of perspective than with any external drama. The importance of this inquiry lies in what it does to our understanding of ourselves, our place in the grand sweep of time, and the very nature of knowledge itself. On the most immediate and relatable timescale, the human one, considering the profound fragility of records, gives us a deeper and more poignant appreciation for the knowledge that we do possess. Think of the great libraries of the ancient world. The Royal Library of Ashurbanipal in Nineveh, which held tens of thousands of cuneiform tablets inscribed with Sumerian and Akkadian literature, was destroyed in the sack of the city in 612 BC. But the intense fire that ravaged the palace had an ironic effect. It baked the clay tablets, hardening them like pottery, and thus preserving them for future archaeologists to discover. A lucky accident. The great library of Alexandria, a legendary beacon of scholarship in the ancient world, was not destroyed in a single cinematic fire, as is often depicted. Instead, it suffered a slow, tragic decline over centuries, a death by 1,000 cuts from political turmoil, neglect, and multiple destructive events. The result was the irreversible loss of countless unique works of science, mathematics, literature, and history. We know of plays by Sophocles that are lost forever, of scientific treatises by Archimedes that have vanished, of entire histories of civilizations that survive only as brief, tantalizing mentions in other later texts. The human story is riddled with these immense, silent gaps, with burned libraries, decayed scrolls, forgotten languages, and cultures whose entire worldview has turned to dust. Recognizing this pervasive loss doesn't diminish our history. It makes the surviving fragments infinitely more precious. It reminds us that our collective memory is a fragile, flickering candle that generations of scribes, librarians, and scholars have worked desperately to keep lit against the perpetual winds of time, war, and decay. Contemplating this human-scale erasure teaches us a form of intellectual gratitude and humility. It underscores that what we know is a treasure salvaged from a sea of forgetting. Now let us zoom out from the timescale of human civilizations to the vast, almost incomprehensible timescale of geology. The stakes here become even more profound, yet somehow quieter and less personal. If human history is a flickering candle, The geological history of the planet is a library built on the slopes of an active volcano, constantly subject to lava flows, earthquakes, landslides, and acid rain. The forces that erase the planetary record are not rare, exceptional events. They are the normal, continuous, and fundamental operating principles of the planet. The Earth's crust is in a state of perpetual, majestic motion. Through the process of plate tectonics, new crust is constantly being created at mid-ocean ridges where magma wells up from the mantle. To make room for this new crust, old crust must be destroyed elsewhere. This happens at subduction zones, where one tectonic plate slides beneath another and is recycled back into the hot mantle. The entire floor of the Pacific Ocean, for example, is recycled on a time scale of roughly 200 million years. This means that there is virtually no ocean floor on Earth that is older than the time of the dinosaurs. Let that sink in for a moment. Any record of life, of climate, of geology that was written on the crust of the oceans during the first 95% of Earth's history has been systematically, completely, and irrevocably erased. It has been melted down, its components stirred back into the planet's interior to be used again. This isn't a flaw in the system, it is the system. This relentless recycling is part of what keeps our planet geologically alive. It powers the volcanoes that created our atmosphere. It builds the mountains. It drives the chemical cycles that regulate our climate. But a direct and unavoidable consequence of this planetary vitality is a profound and permanent form of geological amnesia. The planet stays alive in a very real sense by forgetting its own past. Why does this matter? It matters because it fundamentally reframes our relationship with time and knowledge. Our civilization has existed for a mere handful of millennia. Our species, Homo sapiens, for a few 100,000 years. The entire story of complex multicellular life since the Cambrian explosion covers about 540 million years. This seems like an immense, almost eternal, span of time to us. But the Earth itself is about 4.54 billion years old. The story that we are able to read from the fossil and rock record, as vast and detailed as it seems, covers only the most recent chapters of the planet's existence, perhaps the last 10 to 15%. To believe that the principles, patterns, and rules we have derived from this most recent era are representative of the entire 4.5 billion year history of the planet is an extraordinary leap of faith. It is a bit like reading the final chapter of a vast, epic novel and assuming you now understand the motivations of all the characters and the intricacies of the plot from the very beginning. Considering the possibility of a history erased by deep, geological processes forces us to confront the severe limitations of our own vantage point. It suggests that the world might have gone through phases and states of being that are utterly alien to the one we know, states for which no record could possibly have survived. It allows for the possibility of different kinds of biological experiments, different atmospheric compositions, different planetary dynamics whose entire stories were told on a crust that has long since been unmade. This idea challenges our subtle, often unconscious belief in linear, progressive history. We tend to view history, whether human or planetary, as a straight line leading inexorably to us. We look back at the fossil record and see a story of increasing complexity, a ladder of evolution that seems to have our own existence as its preordained and triumphant endpoint. But if the record is fundamentally, systematically incomplete, if entire epochs of the story are missing, then that simple, linear narrative becomes much harder to defend. Perhaps history is not a straight line, but a series of overlapping cycles of grand experiments of worlds built and then dismantled. Perhaps our world is just the latest of these experiments built upon the ruins and recycled materials of countless predecessors. This is not a frightening or nihilistic thought. It can be a deeply liberating one. It releases us from the subtle burden of feeling like the pinnacle of creation and instead reframes us as humble participants in an ongoing, ancient, and deeply mysterious process. It replaces a brittle sense of certainty with a resilient and expansive sense of wonder. The stakes, then, are not about uncovering some lost civilization or rewriting a textbook. The stakes are about cultivating a perspective of deep humility. It is about learning to see the world not just as a repository of answers for us to find, but as a source of ever deeper questions. It matters because it helps us to hold our knowledge with grace, to be aware of its boundaries, and to stand before the immense, silent gaps in the story with a quiet and profound sense of awe. As we move forward into the heart of our inquiry tonight, let's gently open a few loops. Think of these as threads of thought, briefly introduced now with the quiet promise that we will return to them later, weaving them into the larger pattern of our exploration as we go. There is no need to grasp them tightly, to memorize them, or to anticipate where they will lead. Simply notice them, as you might notice intriguing side paths on a long walk through a forest, paths that you know you will have time to explore before the day is done. This gentle act of promising a return can help to relax the mind, assuring it that no detail will be overlooked or forgotten, and that the story will unfold in its own time, at its own unhurried and natural pace. These are markers we are placing in the landscape of our conversation so we can find our way back to them when the time is right. The first thread we will leave dangling for now is a curious and profound feature in the geological record, a mystery known by a simple yet deeply evocative name, the Great Unconformity. In many places around the world, from the bottom of the Grand Canyon in Arizona to the windswept coasts of the Scottish Highlands, geologists have observed a stark and puzzling gap in the layers of rock. They see layers of relatively young sedimentary rock, say, from the Cambrian period about 500 million years ago, sitting directly on top of much, much older crystalline basement rock, granite or schist, that might be over 1.5 billion years old. It's as if an entire chapter, or in some cases more than a third, of the Earth's autobiography has been physically ripped out of the book. 1 billion years of time, of history, of potential fossils, of accumulated deposits, gone. We will return to this immense, silent gap, this clean, sharp line in the stone book of the world. We will ask, what kind of process or combination of processes could be powerful enough to erase 1 billion years of history across a continental or even global scale? We will wonder what this silent plane of missing time might tell us about the planet's capacity for profound, system-wide self-erasure. It stands as a physical, tangible reminder that the story written in the rocks is not always a continuous narrative, and that its silences can be as meaningful as its words. The second thread relates to the very tools and methods we use to read the past. Our ability to determine the absolute age of ancient rocks is one of the great triumphs of modern science, built primarily on the beautifully predictable clockwork of radioactive decay. This has allowed us to put a firm age on the Earth, the Moon, and the major events in our planet's history with remarkable confidence. But every instrument, no matter how sophisticated, has its limits, and every method has its inherent blind spots. What happens when we are looking for a history that was written in a medium that we don't yet know how to read? Or what if a past world was built from materials and life forms that left no lasting chemical or physical signature that our current tools are designed to detect? Later in our journey, we will come back to this idea, considering the pervasive role of survivorship bias in our understanding of the past. We read the story that is told by the survivors, the hard minerals like zircon that can withstand eons of unimaginable heat and pressure. But what about the stories of the things that didn't survive? We will gently probe the boundaries of our own methodologies, not to discredit their power, but to honestly understand the shape of the darkness that lies just beyond the reach of our lamps. This isn't an exploration of the limits of science, but rather a humble accounting of where its light currently ends and where the great wilderness of the unknown begins. And the third thread, perhaps the most subtle and far-reaching, is about the planet as a single, integrated system. We often think of the Earth in terms of its component parts neatly filed into different scientific disciplines: the geology, the atmosphere, the oceans, the biosphere. But these are not separate things. They are deeply and inextricably intertwined, constantly influencing one another in a web of complex feedback loops that has been evolving for billions of years. Life fundamentally alters the chemistry of the atmosphere. The atmosphere weathers and erodes the rocks. The rocks in turn provide the essential nutrients for life. It is a single, vast conversation that has been going on since the planet's youth. Later in our exploration, we will delve deeper into this idea of the Earth as a self-regulating system, one that seems to work over long timescales to maintain a certain equilibrium, a state of relative stability that is conducive to life. We will ask a simple but profound question. What functional role might the process of erasure, the systematic recycling of materials, and the wiping of old records play in the long-term stability of such a complex system? Could it be that a planet, much like a complex organism, needs to forget to shed its old skins to clear away the accumulated records of its past experiments in order to remain stable, resilient, and habitable over the vast, challenging expanse of geological time? We will consider whether the constant loss of history might be, in some strange and profound way, a necessary feature for the persistence of a living world. So, let these three thoughts hang in the air for a little while, like faint constellations in the twilight sky, the tangible mystery of the great unconformity, the inherent limits of our own tools of perception, and the idea of erasure as a functional, perhaps even necessary, part of a living planetary system. There is no need to connect them yet. We have simply planted them as seeds in the garden of our curiosity. In time, we will return to see how they have grown and how their branches might reach out to intertwine with one another. For now, it is enough to know that they are there, waiting for us patiently down the path. To ensure our exploration tonight is grounded, clear, and built on a shared understanding, it helps to pause and agree on the meaning of a few key terms. The language we use acts as the container for our thoughts, and by defining our concepts in simple, plain language terms, we can build our inquiry on a solid and stable foundation. We will avoid the trap of piling up jargon for its own sake. Instead, for each concept, we will first define it, and then immediately try to translate it into a more intuitive or metaphorical form. Think of this process as laying down a few smooth, flat stones to serve as our footing before we wade out into the deeper, more mysterious waters of our question. The first and most central concept is deep time. This term was first given its profound modern meaning by the 18th century Scottish geologist James Hutton. While observing the landscapes of his native Scotland, he realized that the slow, almost imperceptible processes of erosion and sedimentation he could see happening around him, if projected back over a long enough period, could account for the creation of the most dramatic geological features. At a place called Sycamore Point on the Berwickshire coast, he saw a now famous rock formation where layers of red sandstone were lying horizontally on top of much older, vertically tilted layers of greywacke. He understood, in a flash of insight, that an entire world of mountains must have been formed from these older layers, then tilted up to a vertical position, and then completely eroded away to a flat plain before the new layers of sand could be deposited on top. It was a history of multiple worlds, one after another. His friend and companion John Playfair, who was with him that day, later wrote of the experience that the mind seemed to grow giddy by looking so far into the abyss of time. That feeling of intellectual vertigo, that is deep time. It is a scale of time so vast, so inhuman, that our minds, calibrated for the familiar rhythms of days, seasons, and lifetimes, cannot intuitively grasp it. It is the time scale on which mountains are born and die, on which continents drift across the globe, like colossal ice flows, and on which the slow, patient work of dripping water can carve immense canyons. For our purposes tonight, let's think of deep time as planetary time. It is the Earth's own clock, and its ticks are measured not in seconds or years, but in millions and billions of years. When we speak of history being erased, we are speaking of erasure that happens on this clock. The next essential term is the geological record. This refers to the story of the Earth as it is written in its layers of rock. For the most part, this means sedimentary rocks like sandstone, shale, and limestone, which are formed from the accumulation of sand, silt, mud, and the mineralized remains of living organisms. These materials are typically laid down in layers or strata over eons in places like oceans, lakes, and river deltas. The fundamental principle for reading this record is the law of superposition, a simple but powerful idea which states that in an undisturbed sequence of layers, the oldest layers are at the bottom and the youngest are at the top. Think of the geological record as the planet's great library, and each layer of rock is a page, or perhaps a chapter. By studying these pages, their composition, their chemical signatures, and the fossils they contain, we can reconstruct what the world was like at the time that page was being written. But as we have begun to see, this is a library in a state of constant, catastrophic disrepair. Many of its pages are missing, some are smudged beyond recognition by heat and pressure, and entire volumes have been systematically burned. So whenever we talk about the geological record, we must always hold in our minds this image of a partial, fragmented, and heavily edited text. Now let's define the primary mechanisms of that editing, the great forces of planetary erasure. The first is erosion. This is the process by which rock is broken down and carried away by the action of wind, water, ice, and gravity. It is the relentless sanding, sculpting, and planing of the Earth's surface. A river carving a canyon, a glacier scraping a valley down to bedrock, waves crashing on a coastline, and turning cliffs into sand. This is erosion in action. Over human timescales, it often seems slow, almost imperceptible. But on the clock of deep time, erosion is a force capable of leveling the highest mountain ranges. For our purposes, let's think of erosion as the planet's act of sanding the slate clean. It relentlessly wears down the high points, removing the record that was written there, and carries the resulting debris away to be deposited somewhere else, to begin writing a new story. The second primary mechanism is subduction. This is a core part of the theory of plate tectonics. The Earth's outer shell, its lithosphere, is not a single solid piece, but is broken into a mosaic of large, rigid plates that are constantly, slowly moving. In some places, these plates are pulling apart, and new crust is forming from upwelling magma. In other places, they are colliding. At a subduction zone, one plate, typically a dense oceanic plate, dives beneath a less dense continental plate and is forced down into the Earth's hot mantle, where it is heated, melted, and recycled back into the planet's deep interior. This process is the planet's ultimate recycling program, but it is also an act of total, unrecoverable, archival erasure. Any history that was recorded on that subducting plate, any unique fossils of deep-sea creatures, any evidence of past climates written in its sediments, any strange magnetic signatures from the deep past, is completely and utterly destroyed. Let's visualize subduction as the planetary act of throwing the page into the fire. The information is not just lost or misplaced, its very physical medium is unmade. Finally, let's clarify what we mean by the word history itself in this context. Tonight, history is not just the story of humanity or even the story of life. It is the full, unabridged sequence of states and conditions that the Earth has passed through since its formation 454 billion years ago. This includes its geological history, the arrangement of its continents and oceans, its climatic history, the temperature and composition of its atmosphere, and its biological history, the story of life's evolution and extinctions. It is the complete, hypothetical record of the planet's entire 4.5 billion-year journey. A rewritten history, in our quiet, metaphorical sense, is the narrative that science has skillfully and painstakingly constructed from the surviving fragments of that record. It is not a fabrication but a brilliant interpretation, a good faith effort to fill in the immense blanks and create a coherent story from a deeply incomplete archive. The erased history, then, is everything that has been lost from that archive, whether through the slow sanding of erosion or the fiery recycling of subduction. It is the silent majority of planetary time, the story of all the events for which no evidence remains. So, with these working definitions in place, deep time as the clock, the geological record as the fragmented book, erosion as the sanding of the pages, subduction as the burning of the pages, and history as the full story we are trying to read from the wreckage, we can now proceed with a shared language and a clear sense of our terms. We have our bearings. We can now begin to trace the faint, ghostly outlines of the stories that might have been told in the lost volumes of the Earth. To truly appreciate the scale of potential planetary erasure, it can be helpful to start with a brief sketch of how we came to understand the story we currently tell. The history of our knowledge about Earth's history is in itself a fascinating story of slowly peeling back layers of deeply ingrained assumption and discovering a world far older, more dynamic, and more alien than we had ever dared to imagine. It is a story about learning to read a new and difficult language, the language of stone and time. For much of recorded human history, across many cultures, the world was considered to be quite young. In the Western world, the most influential calculations were based on biblical chronologies, which suggested that the Earth was only about 6,000 years old. This was not a foolish or unscientific belief. It was a perfectly logical conclusion drawn from the most trusted and authoritative historical records available at the time. Within this framework, the Earth's landscape was seen as a relatively static stage, created in more or less its present form, upon which the brief and dramatic story of humanity was unfolding. The idea of a planet with its own vast pre-human history, a history of its own physical and biological evolution, was not yet part of the common mental furniture. The world was the unchanging backdrop to our story. The revolutionary shift began in the late 18th and early 19th centuries with the rise of geology as a formal science. Thinkers like James Hutton, whom we've already met, began to look at the land not as a static creation, but as a dynamic system in constant slow-motion flux. They championed a revolutionary idea that came to be known as uniformitarianism, which is the principle that the same natural laws and processes that we can observe operating in the universe today have always operated in the universe in the past and apply everywhere. In its simplest terms, it is the profound idea that the present is the key to the past. By observing the slow, steady action of a stream carrying silt or wind eroding a rock face, they could infer the immense spans of time that must have been required to build up the colossal layers of sedimentary rock they saw in cliffsides, or to wear down entire mountain ranges. This was a radical departure from previous thought. It recast the Earth not as a passive stage, but as a dynamic and ancient protagonist in its own right, a system that had been actively shaping and reshaping itself for an immense, and perhaps even eternal, period of time. This was the conceptual birth of deep time. At around the same time, others like William Smith, an English surveyor and canal digger, were creating the first large-scale geological maps. While overseeing the excavation of canals, he noticed a curious and unvarying pattern. Different layers of rock always appeared in the same sequential order, and each distinct layer contained its own unique collection of fossils. This discovery, which became known as the principle of faunal succession, was a breakthrough. It allowed geologists to start correlating rock layers across great distances. If they found a rock layer in one part of the country with a specific type of trilobite fossil, and another layer 100 miles away with the same fossil, they could be reasonably sure that those layers were formed at the same time. Fossils became the chapter markers, the index system for the great stone book of the world. For the first time, the history of the Earth had a chronology, albeit a relative one. We could now say with confidence that the age of dinosaurs came after the age of trilobites, and the age of mammals came after the age of dinosaurs, but we couldn't yet say how many years separated them, or when, in absolute terms, they had occurred. The question of the Earth's absolute age remained one of the greatest scientific puzzles of the 19th century. As we mentioned, Lord Kelvin attempted to solve it using the elegant laws of thermodynamics, calculating how long a molten Earth would take to cool to its present temperature. His estimates, which stubbornly remained below 100 million years, were immensely influential but deeply unsettling to geologists and biologists like Charles Darwin. Darwin, in particular, felt that his theory of evolution by natural selection, which relied on the slow accumulation of tiny changes over vast periods, required a much, much older Earth. The debate was fierce, pitting the seemingly infallible authority of physics against the field observations of geology and biology. The deadlock was finally and spectacularly broken by an entirely new discovery at the turn of the 20th century: radioactivity. When scientists like Henri Becquerel, Marie Curie, and especially Ernest Rutherford began to understand that certain elements decay into other elements at a constant, predictable rate, they realized they had stumbled upon the ultimate geological clock. The rate of decay of an element is expressed as its half-life, the time it takes for half of a sample of a radioactive parent element to decay into its stable daughter element. By measuring the ratio of the parent to the daughter element within a mineral crystal, geologists could calculate precisely when that crystal had solidified from magma or lava. This technique, called radiometric dating, was first applied to rocks in the early 1900s. The very first results were stunning, pushing the age of the Earth into the hundreds of millions and then billions of years. It provided more than enough time for the grand, slow processes of evolution and continental drift. After decades of refinement, and by dating not just the oldest Earth rocks but also meteorites that are believed to have formed at the same time as our solar system, the age of the Earth was confidently and consistently established at around 4.4 billion years. This brief snapshot of our scientific journey is important for our inquiry tonight for two crucial reasons. First, it vividly demonstrates how provisional and evolving our understanding always is. The story has changed dramatically over time, with each new discovery forcing a major revision of the entire narrative. The 6,000-year-old Earth was a good faith model based on the best available textual evidence. Kelvin's 100-million-year-old Earth was a brilliant good faith model based on the best available physical evidence. Our current 4.54 billion-year-old Earth is our current good faith model based on the physics of radioactive decay. Each model was built on the most powerful information of its time. This history should instill in us the humility to accept that our current model, as powerful and well supported as it is also likely incomplete and may be subject to future revisions as new and unexpected discoveries are made. Second, and more central to our theme, this history highlights that our entire detailed timeline of Earth's history is built upon the foundational assumption that a readable record has survived the ravages of time. Radiometric dating works beautifully on the tiny, durable zircon crystals that have survived, but it cannot tell us anything about the rocks that were completely eroded to sand or subducted back into the mantle, and thus no longer exist for us to sample. Our history of the Earth is, by absolute necessity, a history of the survivors. With this context in mind, the story of how our own story was built, we can now turn our attention to the immense and relentless processes that have been working, for billions of years, to unbuild it. Let's begin our first deep exploration into the nature of erasure by looking at patterns on a scale we can more easily comprehend and feel: the human scale. The ways in which our own histories, both personal and collective, are lost, fragmented, and misinterpreted can serve as a powerful and intuitive analogy for the much grander, colder, and more impersonal processes that shape the geological record. Before we can truly grasp what it means for a planet to forget its own past, we must first appreciate the many ways a civilization, and even a single human mind, can forget its own. At the very heart of human history lies a simple, sobering, and undeniable fact. The vast majority of everything that has ever been written, spoken, or even thought by human beings is now gone forever. Consider the medium. For millennia, the records of our species were entrusted to profoundly fragile materials. A story told around a fire dies with the last person who remembers it. A thought, unless spoken or written, vanishes in an instant. The earliest writing was inscribed on clay tablets, a relatively durable medium, but one that is heavy, bulky, and brittle. Later came papyrus, made from reeds, a revolutionary step forward in portability, but a disaster for long-term preservation. In the damp climates of Europe, papyrus scrolls would rot and turn to dust in a matter of decades. The immense body of Greek and Roman literature, philosophy, and science that we possess today survived almost entirely because a small fraction of it was painstakingly copied by hand onto more durable animal skin parchment in the scriptoriums of monasteries and the great libraries of cities like Constantinople. But even parchment, a far more resilient medium, is vulnerable to the simple, destructive power of fire. The destruction of libraries, whether through accident, neglect, or deliberate intent, represents a catastrophic and irreversible loss of information. The famous Library of Alexandria, as we've noted, did not disappear in a single dramatic event, but through a long, slow decay, a death by 1,000 cuts from civil wars, changing political priorities, and multiple destructive fires over centuries. We can only guess at the unique works of literature, science, and philosophy that vanished forever within its walls. In 612 BC, the Assyrian city of Nineveh was sacked by a coalition of Babylonians and Medes, and its great library, holding tens of thousands of clay tablets, was burned. In a strange and wonderful irony, the intense fire that destroyed the palace also baked the clay tablets, hardening and preserving many of them for archaeologists to find thousands of years later. A lucky accident of chemistry that saved a fragment of the world's first great literary epic, the Epic of Gilgamesh. The Mayan codices, intricate and beautiful folding books made from bark paper, recorded centuries of history, astronomy, and ritual knowledge. In the 16th century, Spanish conquistadors and clergy, viewing them as heretical works of idolatry, systematically gathered and burned them. Of the thousands that must have once existed, only 4 are known to have survived into the present day. This is a pattern we see again and again throughout human history. The record of human experience is incredibly, tragically fragile. What survives to us is not a complete and accurate representation of the past, but a tiny, biased, and often completely random sampling. It is the story told by the lucky few who survived the fire, the flood, the conquest, the censorship, and the slow, quiet, inexorable decay of time. This leads to a crucial and profound implication. Our understanding of the past is shaped as much by what is missing as it is by what is present. The absence of records creates a kind of historical dark matter. We know it must have been there, the thoughts, the stories, the daily lives of billions of people, but we cannot see it directly. We are forced to infer, to guess, to reconstruct a vast and complex whole from a few scattered, broken parts. Sometimes a single, new discovery can dramatically and unexpectedly change the entire picture. For many centuries, the ancient Hittite civilization was known only from a few brief, puzzling mentions in the Old Testament. Some 19th century scholars even doubted they had ever existed, suggesting they were a biblical fiction. Then, in the early 20th century, archaeologists excavating in central Turkey unearthed their capital city, Hattusa, and along with it, a vast royal archive of thousands of clay tablets. Suddenly, in the space of a few years, a lost empire reappeared in history, complete with its own language, laws, and diplomatic correspondence. The long silence in the historical record was not proof of their absence, but merely an absence of our evidence. How many other cultures, how many other ways of being human, have been lost so completely that we do not even have a name to search for, no puzzling mention in an ancient text to guide our search. Now let's take this human-scale pattern of forgetting and erasure and use it as a lens. Let's scale it up. Let's replace the crumbling papyrus with a layer of eroding sandstone. Let's replace the burning library with a subducting tectonic plate. The specific mechanisms change, but the fundamental principle remains exactly the same. The preservation of a historical record is the rare exception, not the rule. The natural default state of information over very long periods is to decay and disappear. The forces of geology are simply the planetary equivalent of fire, flood, and time, operating on a scale of unimaginable power and scope. Erosion is the slow, steady decay of the record. It is the atmospheric equivalent of papyrus turning to dust in a damp climate. Every minute of every day, wind and water and ice are breaking down the rocks that hold the history of our world, carrying the particles away and blurring the text into illegibility. Subduction is the library fire. It is a catastrophic, irreversible destruction of the record, melting the book and the words within it back into an undifferentiated, primordial medium. The geologic record we have today is the end product of this epic, eons-long battle between two opposing forces: deposition, the process which writes the story by laying down new layers, and erosion and subduction, the processes which erase it. For most of Earth's history, in most of its locations, the forces of erasure have been winning. What does this human-scale analogy imply about the planetary story? It implies that the geological record must be, like our human historical record, a tiny and profoundly biased sample of what has actually occurred. We read the stories that were written in the most durable materials, like the hard shells and bones of animals, which are much more likely to fossilize than soft-bodied creatures, and that happened to be deposited in the most stable and protective environments, like shallow, quiet seas where sediment can accumulate undisturbed. And even then, these records only survive if they are on a piece of crust that has, by sheer geological luck, avoided the destructive processes of major erosion and subduction for hundreds of millions, or even billions, of years. This is an extreme form of survivorship bias. We are building our universal theories of life and planetary evolution based on the evidence from a few lucky, sheltered corners of the world that managed to survive the planet's relentless, ongoing effort to wipe its own slate clean. What might we be missing? What kinds of life forms, what kinds of ecosystems, what kinds of entire worlds might have existed that were never recorded in a medium that could survive, or that were recorded but on a page that has since been thrown into the planet's mantle and burned to plasma? The human analogy doesn't give us the answer, but it gives us a new and powerful question. It encourages us to look at the silent gaps in the rock record not as mere nothingness, but as potential archives of the lost, as the geological equivalents of a library we know for a fact was burned to the ground. If our first track of evidence, drawn from the analogy of human history, suggests that the geological record is profoundly fragile and incomplete, then what are the deeper implications of that fragility? How does accepting this deep, systemic incompleteness change the way we think about the story of our world? This is where we begin to gently stress test the idea. We take our provisional model of a heavily erased history and see what it can help us explain and what new, more interesting questions it allows us to open up. We move from describing the mechanism of erasure to exploring its profound and sometimes unsettling consequences, all while maintaining our calm and curious cadence. The first and most immediate implication is a principle that is fundamental in science and logic, but one that takes on a whole new weight and power when we are dealing with the abyssal depths of planetary time. And that is the principle that an absence of evidence is not and can never be evidence of absence. For a very long time, the fossil record seemed to show a sudden, almost magical, explosion of complex animal life at the beginning of the Cambrian period, about 541 million years ago. In rocks older than this, there were virtually no fossils of complex animals, and then, in a geological instant, the rocks were teeming with them: trilobites, brachiopods, and a bizarre bestiary of creatures with no modern descendants. This event, known as the Cambrian explosion, was so abrupt in the rock record that it deeply puzzled Charles Darwin himself, as it seemed to directly contradict his theory of slow, gradual evolution. For decades, it looked for all the world as though complex life had simply appeared out of nowhere. But as our tools for seeing have become more sophisticated and our search more patient, we have begun to find the faint, ghostly traces of a much older and more mysterious world that came before. In a few rare locations around the globe, we have found impressions of strange, soft-bodied organisms in fine-grained sandstones. These creatures, known as the Ediacaran biota, lived in the hundreds of millions of years leading up to the Cambrian. They were quilt-like, frond-like, and blob-like things with no obvious heads, guts, or limbs, and their preservation was an incredibly lucky accident of circumstance. Because they had no hard parts, they could only leave a record under the most specific and gentle burial conditions. For billions of years before them, life was almost entirely microscopic: bacteria and archaea. The story of the sudden explosion is now being rewritten as the story of a very long, slow fuse, most of which was invisible to us simply because the life forms were too small, too soft-bodied, or lived in environments whose rocks were not well preserved. The gap in the record was not a gap in existence, it was a gap in preservation. Now let's apply this logic more broadly and more radically. If we have had such tremendous difficulty seeing the direct, soft-bodied ancestors of the life we know today, what are the chances we could see evidence of a completely different experiment in biology that was erased entirely? The possibility is not zero. A world of life forms that did not produce hard shells or skeletons, that was based on a slightly different chemistry, and that lived out its entire history on a piece of continental crust that was later eroded to nothing, or an oceanic plate that was later subducted, could have existed and left not a single unambiguous trace for us to find. Acknowledging this forces us to hold our timeline of life with a bit more humility. The story we know is the story of a particular lineage that happened to invent durable, easily fossilized body parts and lived in the right places at the right times to be preserved. It might not be the only story that has ever been told on this planet. Let's consider another edge case, this time in the realm of climate. We build our models of the Earth's past climate based on proxies, indirect evidence found in ice cores, tree rings, and the chemical composition of microscopic shells in deep-sea sediments. These are powerful and ingenious tools, but they provide a relatively recent and high-resolution snapshot of a climate system that has been operating for billions of years. We generally assume that the fundamental physics and chemistry of the system have always been the same, which is a very reasonable starting point. But what if there were stable states of the Earth system so different from our own that they would leave behind no recognizable proxy signature? Imagine a world with a much thicker, Venus-like atmosphere, or with shallow, globe-spanning oceans of a radically different chemical composition. The fundamental rules of physics and chemistry would still apply, but the results could be a planetary environment with no modern analog, a world we would struggle to even imagine. The geological records left by such a world, if any, survived the gauntlet of deep time, might be so strange that we would struggle to interpret them correctly. We might dismiss them as anomalies, as data errors, or as the products of some bizarre, localized process because they don't fit into our existing models of how the Earth is supposed to behave. The incomplete nature of the record, therefore, doesn't just hide information from us. It also fundamentally biases our imagination. We can only build models based on the data we have. And if that data is a filtered, partial, and biased record of what has actually occurred, then our models of what is possible for a planet like ours will necessarily be a filtered, partial, and biased representation of the full reality. This brings us to a final, more philosophical implication of a deeply erased record. If the Earth is constantly writing, erasing, and rewriting its own history, then perhaps there is no such thing as a single, final, authoritative story of the planet. Perhaps the reality of the Earth is more like a piece of music than a book. A book has a fixed and final text, but a piece of music is only ever realized in its performance. Each performance can be different, emphasizing different themes played at a different tempo with a different feeling. Our scientific understanding of Earth's history is one such performance, based on the surviving fragments of the original score. It is a beautiful, powerful, and coherent interpretation, but it is not, and can never be, the only possible one. A new discovery, a new fossil in an unexpected place, a new way of analyzing chemical isotopes, a new understanding of mantle physics, can act like a new conductor, reinterpreting the score and creating a performance with a whole new feeling and a whole new meaning. The idea of an erased history invites us to think of the planet not as a static object of study, a problem to be solved, but as a dynamic and ongoing process. The story is not over. The planet is still changing, still editing, still creating new geological records while destroying old ones. We are living in the middle of a sentence whose beginning is lost and whose end is not yet written. This perspective can be deeply calming. It releases us from the anxious need to have a complete and final answer. Instead, it allows us to be content with the process of discovery itself, to find joy and wonder in the piecing together of the fragments, while always maintaining a profound and quiet respect for the immense, silent mystery of the parts that are forever lost. Having explored the idea of erasure on a human scale and its humbling implications, let us now zoom out to a much wider and more abstract perspective. Let's begin to look at the Earth not as a collection of individual parts, rocks, oceans, air, life, but as a single, integrated system, a vast and intricate network of interconnected cycles and feedback loops. This view allows us to move beyond the simple, passive idea of a record being lost by accident and to ask a more sophisticated and intriguing question. What functional role, if any, might the very process of erasure itself play in the long-term stability and persistence of a living planet? All complex systems that maintain a relatively stable state over long periods of time, from a single living cell to a national economy to a star, rely on the interplay of feedback loops. A feedback loop is a circuit in which the output of a system is fed back in as an input, either dampening or amplifying the system's subsequent response. A negative feedback loop is stabilizing. It acts to counteract change and maintain a state of equilibrium, a condition known as homeostasis. The classic example is the thermostat in your home. When the temperature rises above the desired set point, the thermostat sends a signal to turn on the air conditioning, which cools the room back down towards the set point. When the temperature falls too low, it signals the heat to turn on, which warms the room back up. The system constantly works to oppose any deviation from the norm, thus keeping the temperature remarkably stable despite fluctuations in the outside weather. The Earth's climate system is governed by countless such negative feedback loops. One of the most important and powerful is the long-term carbon cycle, also known as the carbonate-silicate cycle. In very simple terms, it works like this. Volcanic eruptions release carbon dioxide, a greenhouse gas, into the atmosphere, which causes the planet to warm. This warming increases the amount of evaporation from the oceans and consequently the amount of rainfall. This increased rainfall, which is slightly acidic, increases the rate at which silicate rocks on the continents are chemically weathered. This weathering process draws carbon dioxide out of the atmosphere, combines it with dissolved minerals in rivers, and eventually deposits it on the ocean floor as carbonate rocks like limestone. The net effect is that if the planet gets too warm, weathering speeds up, pulling more carbon dioxide out of the atmosphere and cooling it down. If the planet gets too cool, weathering slows down, allowing volcanic carbon dioxide to build up in the atmosphere and warm it back up. This planetary-scale thermostat, operating over millions of years, has kept the Earth's climate within a habitable range for billions of years despite massive changes in the Sun's brightness and the planet's atmospheric composition. It is a powerful force for long-term stability. In contrast, a positive feedback loop is amplifying. It takes an initial change and pushes the system further and further in the same direction. Think of the loud, high-pitched feedback you get from a microphone held too close to a speaker. A small, stray sound is picked up by the microphone, amplified by the sound system, comes out of the speaker, is immediately picked up again by the microphone, and is amplified even more, creating a rapidly escalating runaway screech. Positive feedback loops can lead to dramatic, sometimes catastrophic, state changes in a system. The modern problem of climate change provides a stark and worrying example. As the planet warms due to human emissions, the bright white sea ice in the Arctic melts. The dark, open ocean water that replaces the reflective ice absorbs much more sunlight, which causes even more warming in the region, which in turn melts even more ice. This is a reinforcing cycle that accelerates the initial change, a runaway process that can be very difficult to stop once it gains momentum. Now let's place the grand geological mechanisms of erasure, erosion, and subduction within this framework of systems and feedbacks. These are not just random destructive acts happening in isolation. They are fundamental, non-negotiable components of the Earth's great biogeochemical cycles. In fact, they are the physical machinery that drives the most powerful negative feedback loops that keep the planet stable over geologic time. Subduction, the fiery erasure of the oceanic crust, is not just about destroying a historical record. It is the descending arm of the giant convection cells in the Earth's mantle that drive plate tectonics. This majestic, slow-motion churning is what powers the volcanism that releases the very gases that regulate the climate through the carbon cycle. The recycling of the oceanic crust back into the mantle also returns crucial elements, water, carbon, nitrogen, to the deep Earth to be outgassed again in the future. It is a core part of the planet's long-term circulatory system. Without this constant process of destruction and renewal, the entire system would eventually seize up and the planet would become geologically dead. Similarly, erosion, the slow, patient erasure of the continents, is not just about wearing down mountains and turning them to sand. It is the critical first step in the chemical weathering process that draws carbon dioxide from the atmosphere. The breaking down of rock into smaller particles vastly increases the surface area available for chemical reactions to occur. The erosion and subsequent transport of these rock particles into the oceans also provides the essential, life-limiting minerals, phosphorus, iron, silica, that marine life, particularly the phytoplankton, at the base of the entire marine food web, depends on. The very act of erasing the high places is what nourishes the oceans and regulates the global temperature. From this system's perspective, the erasure of the geological record is not a flaw or an accident. It appears as an inextricable byproduct and perhaps even a necessary functional component of the planet's self-regulating machinery. The very same processes that erase history are the very same processes that maintain planetary habitability over deep time. The Earth stays alive by constantly turning over its own substance, by recycling its crust, its water, and its atmosphere in grand, eons-long cycles. And a necessary, unavoidable consequence of this constant, deep recycling is the destruction of most of the records of its own past. In a very real sense, the planet's memory is sacrificed for its stability. It is a system that seems to prioritize the functioning of the present over the preservation of the past. It maintains its dynamic equilibrium not by carefully preserving every state it has ever been in, but by constantly and systematically letting go of them. It is a system built not on accumulation but on flow. This represents a profound shift in perspective. It suggests that we should not be surprised by the immense gaps in the geological record. The real surprise, from a system's point of view, is that any record survives at all. The existence of any rock older than a few 100 million years is a testament to a profound stroke of geological luck, a corner of the world that managed for a time to escape the relentless planet-spanning engine of renewal. What then are the second-order effects, the deeper and more subtle implications of seeing erasure not merely as a bug of history, but as a functional feature of a self-regulating planetary system? This is where our provisional model begins to yield some truly interesting and thought-provoking insights. It has the potential to shift our entire emotional and philosophical orientation toward the planet and our place within its ancient, ongoing story. If the very processes that maintain a habitable present are the ones that systematically erase the deep past, then it suggests a fundamental, perhaps even tragic, trade-off at the very heart of the planetary system. The Earth, it seems, cannot simultaneously preserve a perfect high-fidelity record of its history and maintain the dynamic, life-sustaining cycles that we and all other living things depend on. It is a choice between memory and metabolism, between archive and activity, and the planet has, through the simple, unthinking laws of physics and chemistry, overwhelmingly chosen metabolism. It has chosen life in the present moment over the permanent preservation of its own vast archives. This gives the silent gaps in the rock record a whole new meaning. They are not just silent, empty voids where nothing was written or the writing was lost. They are, perhaps, the ghost imprints of planetary functioning. They are the price of stability. When we look at a great unconformity, that billion-year gap in the stone book of the world, perhaps we are not just seeing a missing chapter. Perhaps what we are really seeing is a scar, a healed wound, left by a planetary system working overtime to keep itself in balance. It might represent a long period of intense, continent-wide erosion that was necessary to draw down greenhouse gases and cool the planet after a runaway warming event, or a massive pulse of subduction needed to reset the chemistry of the oceans after some ancient perturbation. The silence in the record from this perspective might not be an empty silence at all. It could be the resonant, quiet hum of a system that has successfully regulated itself back to health, back to a state of habitability. The erasure is the evidence of the cure. This perspective also allows us to think about planetary sensitivity and path dependence in a new way, without ascribing any kind of conscious intention or purpose to the system. A system that constantly recycles its core components is, by its very nature, path-dependent. The state of the Earth today is a direct result of the specific materials and conditions that were available to it after the last great recycling event. Imagine a baker who makes a new loaf of bread each day, but always uses a bit of leftover sourdough starter from the loaf made the day before. The bread today is profoundly influenced by the bread of yesterday and the day before that, but it has no direct connection to the bread from a year ago, because that lineage of starter, that specific history of yeast and bacteria, is long gone. Similarly, the Earth system today is building its present reality, its atmosphere, its oceans, its life, out of the recycled remnants of its relatively recent past, not its deep past. The deep past has been almost entirely remelted, remixed, and reconstituted. This could mean that the planet has the capacity to undergo profound reboots, to effectively forget certain states, or unlearn certain biological or chemical solutions. An early version of life, for example, might have arisen and created a particular kind of atmospheric chemistry that was stable for a time. But if a major geological event like the assembly of a supercontinent triggered a massive planet-wide wave of subduction and erosion, it could have so thoroughly altered the surface conditions, the ocean chemistry, the nutrient flows, the climate, that the old system was completely and irrevocably erased. When the planet eventually restabilized, it might have found a completely new equilibrium with a different kind of atmosphere and a different kind of life taking hold, a new system with no memory whatsoever of the system that came before. This chain of if-then logic, born from a systems thinking perspective, leads us to a remarkable and mind-expanding conclusion. The planet might be able to undergo fundamental reboots, wiping its own operating system and installing a new one from scratch. The erased history isn't just a lost story, it is a lost world, a lost set of operating parameters, a lost paradigm of existence. What this model gives us is a framework for imagining a planet with a far more radical, experimental, and discontinuous history than is suggested by the smooth, continuous parts of the geological record we are most familiar with. It allows for the possibility of multiple, distinct Earths throughout history, a succession of worlds built from the same raw materials but operating on different principles, each one separated from the next by a great erasure event. This doesn't require any mysterious or unknown forces, only the known mechanisms of plate tectonics and climate feedback, operating with different intensities and in different configurations over the vastness of deep time. It suggests that the history of our planet may not be a single, long-playing song, but a series of different albums, perhaps even in different genres, with long periods of silence in between, where the instruments were taken apart, cleaned, and retuned for an entirely new performance. And it implies that our current world, our current performance, is just that. One version among many that might have been, and many that might yet be. In the middle of this vast cosmic exploration, which carries us across billions of years and through the deepest structures of the planet, it can be grounding to pause for just a moment, to come back from the abstract and the immense to a sense of shared human presence. So, wherever you are right now, whatever time of night it might be for you, in your specific corner of the world, just take a moment to notice the quiet, invisible community of listeners. People in their own spaces, in their own beds or chairs, but connected for a little while by this shared thread of curiosity. You are not alone in this journey of thought. In different rooms, in different cities, perhaps even in different countries and continents, others are also listening, also breathing, also contemplating this same quiet mystery alongside you. There is a gentle and reassuring power in that shared attention, a sense that our individual curiosities, when woven together in a moment like this, create something larger, warmer, and more resonant. It is a quiet reminder that the deepest questions are not the property of any single mind, but belong to all of us. If you feel so inclined, you might even take a quick mental note of your location, a neighborhood, a city, a landmark, and the time on the clock, just to anchor this moment in your own reality, to create a small, personal data point in this global network of quiet contemplation. There is no need to share it with anyone, only to notice it for yourself. It is a simple act of acknowledging your own unique place within this shared, temporary experience. In a small way, it connects the grand, abstract ideas of planetary history to the concrete, tangible reality of your own life, right here, right now. And if this journey is proving to be a restful one for you, if these ideas are bringing a sense of calm or a feeling of expansive wonder, we would be grateful if you would consider a very small, very gentle action, perhaps a simple like or a subscribe to the channel where you are listening. These are the quiet signals in our modern world that say, this was worthwhile. This brought me a moment of peace. There is no urgency, It is simply an invitation offered with gratitude for your presence and your attention here tonight. Think of it as a small digital nod to the others who are sharing this space with you. A quiet way of raising a hand and saying, "I'm here too, wondering about these things with you." It helps to make this invisible community feel just a little more real. And now, with that brief moment of connection, let us allow our focus to widen once more, returning to the grand, silent stage of the Earth, ready to explore the next layer of our question. To engage with our central question in the fullest and most honest way, we must not only explore the evidence and ideas that seem to support it, but we must also give a fair, generous, and powerful hearing to the strongest counter-arguments. We must build up the conventional explanation, the mainstream scientific consensus, to its strongest possible form without caricaturing it or creating a flimsy straw man to easily knock down. This is the principle of steel manning, and it is an essential part of rigorous, respectful, and productive inquiry. It ensures that we are not simply indulging in a comfortable fantasy or a one-sided speculation, but are engaging with a real and profound intellectual landscape, complete with its own robust and well-defended structures. So let's pause our speculative journey for a time and carefully, respectfully outline the powerful, coherent, and evidence-based case for why the geological record, while admittedly and obviously incomplete, is still a fundamentally reliable guide to the history of our planet, and why the idea of a completely erased, unknowable history might be a poetic overstatement of the reality. The primary and perhaps most powerful argument for the fundamental reliability of the geological record is the sheer, overwhelming consistency of the story it tells on a global scale. While the rock record in any single location, a particular mountain range, a specific canyon, is full of gaps and unconformities, when we correlate the records from thousands upon thousands of locations across every continent, a remarkably coherent and consistent picture emerges. Geologists have spent 2 centuries painstakingly mapping these layers, cross-referencing their fossil content, and more recently, their radiometric dates. The result of this monumental collective effort is the geologic timescale, a robust and detailed framework that has been tested, confirmed, and refined by countless independent lines of evidence. We find the same predictable sequences of fossils in rocks of the same age in Europe, North America, and Asia. The chemical signatures of major global events like the asteroid impact that marked the end of the Cretaceous period or the massive oxygenation events of the Proterozoic can be found in sedimentary layers from oceans and continents all around the world. This global consistency is a very strong argument against the idea that the record is so fragmented as to be fundamentally misleading. If all the surviving pages from the burned library, when put together, seem to tell a similar and interconnected story, it becomes much less likely that they are just a random, unrepresentative remnant of a completely different book. The narrative, as we have it, holds together with remarkable strength. Furthermore, the conventional model argues that while the mechanisms of erasure, erosion, and subduction are indeed powerful, they are not absolute, nor are they uniform in their effects. Subduction, for instance, primarily destroys the dense basaltic crust of the oceans. Continental crust, which is made of less dense granitic rock, is much more resistant to subduction. It is too buoyant, too much like a cork, to be easily pulled down into the mantle. Instead, when continents collide, they tend to crumple and thicken, building great mountain ranges like the Himalayas. This is why we have continents in the first place, and it is also why we can find rocks on the continents that are incredibly, staggeringly old. The ancient cores of the continents, called cratons, contain rocks that are as old as 4 billion years. These ancient stable blocks of crust are the planet's ultimate archives. While they have certainly been eroded, deformed, heated, and squeezed over their long history, they have survived. They provide a direct, physical window into the conditions of the early history of the Earth. The very existence of these ancient rocks, which have been at or near the surface for billions of years, seems to directly contradict the idea of a complete and systematic erasure of the past. The planet, it seems, does not throw all of its books into the fire. It carefully preserves its oldest and most durable volumes in these vast continental archives. The third strong pillar of the mainstream explanation is the immense predictive power of the current model of Earth history. A good scientific model doesn't just explain what we already know, it makes testable predictions about what we should find in the future. And the standard model of Earth history, encompassing both plate tectonics and biological evolution, has done this with remarkable and repeated success. For example, the theory of evolution predicted that we should find fossil forms that are transitional between major animal groups such as reptiles and birds, or fish and amphibians. And we have the discovery of fossils like Archaeopteryx, with its blend of reptilian, teeth, bony tail, and avian, feathers, features, and Tiktaalik, with its fish-like scales and fins but amphibian-like flat skull and mobile neck, confirmed these predictions with stunning precision, filling in the so-called gaps in the fossil record exactly where the models said they should be. Similarly, the theory of plate tectonics predicted the existence of mid-ocean ridges, deep-sea trenches, and the symmetrical patterns of magnetic striping on the ocean floor long before we had the technology to map the deep oceans in detail. When we finally developed that technology in the mid-20th century, the predictions were confirmed in every particular. This consistent ability to successfully predict what we will find when we look in a new place or with a new tool is perhaps the strongest evidence that our current story, while certainly incomplete in its fine details, is a fundamentally correct and reliable guide to the way the planet works and the broad outlines of the history it has experienced. Finally, the conventional view would argue that the unyielding laws of physics and chemistry themselves place firm constraints on the possibilities of Earth's past. While we can imagine fantastical alien worlds with vastly different conditions, the Earth has always been bound by certain non-negotiable parameters. It has a certain mass, which dictates its gravity. It orbits at a certain distance from a certain type of star, which dictates the amount of energy it receives. And it is made of a certain collection of elements in certain abundances. These fundamental factors severely limit the kinds of atmosphere, the kinds of oceans, and the kinds of geology that are physically possible. While the Earth has certainly gone through states that were very different from today's, a world with a toxic, oxygen-free atmosphere, a snowball Earth covered in ice from poles to equator, these states are still understandable and modelable within our current understanding of physics and chemistry. The idea of a lost history so alien that it would leave no recognizable trace is seen as unlikely because any world that existed on this planet would have had to obey the same fundamental rules. Its chemistry would have left some kind of isotopic signature, its geology some faint structural trace, even in the oldest, most heavily altered and metamorphosed rocks. Proponents of this strong evidence-based view would argue that while we have certainly and lamentably lost the fine details, the individual brushstrokes of history, the major themes, the fundamental composition, and the essential plot of the story are well preserved and accurately understood. The book may have many missing pages, but the table of contents is still largely intact, and the main thrust of the narrative is clear and unambiguous. Having given the mainstream view its due respect, constructing its case as fairly and strongly as we can, let us now, with the same spirit of neutrality and gentle curiosity, present some alternative interpretations of the very same evidence. This is not intended as a rebuttal or the beginning of a debate. It is simply a matter of laying out different ways of seeing the same set of facts, side by side. We are not trying to decide which view is right or wrong. We are simply trying to expand our capacity to hold multiple, sometimes conflicting, possibilities in our minds at once, a practice that is essential for deep, creative, and resilient thinking. The goal is to appreciate the inherent ambiguity and richness of the evidence, and to see how the same set of facts can be used to support different, but perhaps equally compelling, narratives about our planet's deepest past. The first alternative interpretation takes aim at the very consistency that the mainstream model prizes so highly. The standard view, as we've discussed, says that the global consistency of the geological record is powerful evidence of its reliability and fundamental completeness. An alternative view might ask a different question. Could this consistency be in itself a form of profound and systematic survivorship bias? Is it possible that the Earth system has gone through multiple, very different operational states or regimes in its long history, and that the geological record we see today is overwhelmingly the product of just the most recent and perhaps most destructive one? Imagine, as an analogy, a vast ancient forest that has been subject to a series of massive continent-spanning fires over its long history, with each fire being of a completely different type. The first fire, billions of years ago, was a low, fast-moving ground fire. The second, much later, was a slow, intensely hot fire that baked the soil. The third and most recent fire was a catastrophic crown fire that burned the entire canopy and sterilized the upper layers of the earth. After this most recent fire, the forest that eventually regrows will contain abundant and consistent evidence of that specific fire. The surviving trees will all have similar fire scars at a similar height. The soil chemistry will show a consistent signature from that event. An observer arriving after this last fire and studying this forest might develop a very detailed, consistent, and predictive theory of fire behavior based on all the evidence they find. But their theory would only describe the last and most powerful fire. The evidence of all the previous different types of fires would have been completely incinerated, buried, and overwritten by the final, dominant event. Applying this analogy to geology, we know that the current regime of plate tectonics, with its specific style of subduction and continental drift, has been operating for a very long time. It is a very effective, very powerful system for shaping the planet's surface. It is possible that this system over the last billion or perhaps 2 billion years has been so efficient at recycling and reshaping the crust that it has systematically overwritten the evidence of any previous tectonic regimes that may have operated differently in the planet's hotter youth. The consistency we see in the rock record, then, might not be the consistency of the entire story of Earth, but just the consistency of its final, all-consuming chapter. In this view, the ancient cratons, those old continental cores, are not seen as pristine, surviving archives of the early Earth. Instead, they might be viewed as the most heavily edited manuscripts imaginable, rocks that have been so repeatedly heated, squeezed, metamorphosed, and intruded by later magmas that their original text has been almost completely garbled, leaving only the faintest, most ambiguous, and most difficult to read clues to the worlds they once recorded. A second alternative interpretation revolves around the very nature of events in deep time. The standard model tends to interpret the geological record in terms of gradual, continuous changes punctuated by occasional catastrophes, but all operating within a single, unbroken system. An alternative framework might suggest that the system itself can undergo fundamental state changes, like a computer rebooting with a whole new operating system. A key area of uncertainty and debate in modern geology is the exact history of plate tectonics. Did it start early in Earth's history, soon after its formation? Did it start and stop multiple times? Or, as some models suggest, did it operate in a completely different mode in the past, when the Earth's interior was much hotter? Some geophysical models suggest that the early Earth might have had a stagnant lid crust, more like modern-day Mars or Venus, without active, moving plates as we know them. The transition from a stagnant lid regime to our modern active lid plate tectonics would not have been a minor event. It would have represented a complete and violent reboot of the entire planetary system, fundamentally changing how heat escapes from the interior, how the atmosphere and oceans are regulated, and what kinds of environments are available for life. Such a profound state change could provide a powerful and elegant mechanism for a great, world-altering erasure. The very initiation of modern-style plate tectonics could have rapidly subducted and destroyed most of an earlier, primordial crust, a crust that might have held the only record of the first billion or even 2 billion years of Earth's history, a period from which we have almost no surviving rocks. In this alternative view, the great unconformity might not just be a billion-year gap in the record of our current system, but the actual physical scar left by the transition from a previous system to our own. It could be the boundary layer, the firewall between two fundamentally different Earths. We may be living in and reading the record of Earth 2.0, and the records of Earth 1.0 were almost entirely deleted during the planetary scale upgrade. This is a speculative but physically plausible model, and it highlights how different interpretations of the very same piece of evidence, the existence of a vast gap in the rock record, can lead to vastly different and equally compelling narratives about the planet's deepest past. Finally, let's revisit the constraints of physics and chemistry. The standard view is that these immutable laws sharply limit the possibilities of Earth's past. An alternative view would not disagree with this at all, but would instead emphasize that within those unyielding laws, there is a vast, unexplored space of possibilities that we have not yet fully considered, largely because our thinking is anchored by the single example of the world we know. We have only one example of a living planet to study, our own. This is a sample size of one. As a result, we have a natural but powerful tendency to assume that the specific path life took on this planet, based on DNA using water as a solvent, powered by photosynthesis, is the only path that is possible. But we simply don't know that to be true. It is chemically and physically plausible that other forms of life or pre-life could have existed in Earth's early history based on a different chemistry, perhaps using a different solvent or a different method of encoding information, and leaving behind no fossil or chemical trace that our current methods, which are exquisitely tuned to detect our own kind of biology, are capable of recognizing. If such a separate alien experiment in biology existed on early Earth and was then completely wiped out by a planetary scale event, a truly giant asteroid impact, a tectonic state change, or a sudden change in ocean chemistry, its history would be, for all practical purposes, completely and totally erased. The very fact that our form of life is here and is so biochemically uniform and dominant across the entire planet may itself be the result of a contingent historical event that wiped out a competitor. The story we read in the rocks is, by definition, the story of the winners. The alternative interpretation simply and humbly asks us to remember that there might have been other players in the game whose stories are lost forever simply because they did not survive to the final round. To go one layer deeper in our inquiry, we must look not just at the record itself, but at the very methods we use to read it. How do we know what we think we know? What are the inherent limits of our instruments and our techniques? And how might those limits be shaping the story we tell ourselves about the history of the Earth? Acknowledging the boundaries of our perception is not a sign of failure, but a mark of intellectual maturity. It allows us to distinguish between what is robustly known and what is reasonably inferred, and to hold a space for what might be, for now, completely unknowable. The cornerstone of our modern understanding of deep time is the technique of radiometric dating. This method is one of the great triumphs of 20th century science, a seemingly magical tool that allows us to read the birth certificates of rocks that are billions of years old. The principle behind it is beautifully simple. Some naturally occurring elements have isotopes, atoms with the same number of protons but a different number of neutrons, that are unstable. These radioactive parent isotopes decay over time into stable daughter isotopes at a rate that is constant and unaffected by temperature, pressure, or chemical environment. This rate is measured by a half-life, the time it takes for half of the parent atoms in a sample to decay. By measuring the ratio of parent to daughter atoms in a mineral crystal and knowing the half-life of the parent, we can calculate how much time has passed since that crystal first formed, locking the atoms into its structure. For example, uranium-238 decays into lead-206 with a half-life of about 4.5 billion years, making it a perfect clock for dating the age of the Earth itself. This method is incredibly powerful, but it comes with crucial limitations and biases that are central to our question. First, radiometric dating does not date the rock itself, but rather the moment when a specific mineral crystal cooled and solidified from molten rock. This means it is most effective on igneous rocks like granite or basalt. For sedimentary rocks, which are made of bits and pieces of older rocks, radiometric dating will tell you the age of the original parent rock from which a grain of sand was eroded, not the age when the sedimentary rock itself was formed. Geologists have developed clever ways around this, for example by dating layers of volcanic ash that have fallen between sedimentary layers, but the fundamental point remains. Our most precise clock works best on a specific type of material. More importantly, for the clock to be readable, the system must remain closed. That is, no parent or daughter isotopes can be added or removed from the mineral crystal after it forms. If the rock is later subjected to intense heat and pressure, a process called metamorphism, the atoms can migrate and the clock can be partially or completely reset. The date we get from a metamorphosed rock might not be its original age, but the age of the metamorphic event. In a way, metamorphism is a form of informational erasure. It overwrites the original birth certificate with a new one. The ancient continental cratons, which we earlier described as the planet's oldest archives, are almost entirely composed of igneous and metamorphic rocks. This means their records are not of pristine, untouched early crust, but of a crust that has been repeatedly heated, squeezed, partially melted, and recrystallized. Their clocks have been reset, perhaps multiple times. They tell a story, but it is a complex and overprinted story, not a simple, linear narrative of the first billion years. And then there is the ultimate form of survivorship bias built right into the method itself. Radiometric dating can only be performed on minerals that have survived to the present day. The technique relies on finding tiny, incredibly durable crystals that have weathered the immense journey through deep time. The hero of this story is a mineral called zircon. Zircon crystals, which form in cooling magmas, are exceptionally hard and chemically resistant. They incorporate uranium atoms into their crystal structure, but strongly reject lead, which means any lead found in an ancient zircon is almost certainly the product of radioactive decay. They are, in essence, perfect tiny time capsules. The oldest known materials on Earth are zircon crystals, found in Western Australia, dated to be about 4.4 billion years old. These tiny grains, barely the width of a human hair, have survived while the original igneous rocks they formed in have long since been eroded away and turned into something else. But this raises a profound question. We have built our entire timeline of the early Earth on the stories told by these exceptional survivors. But what if the rocks that didn't produce durable minerals like zircon had a different story to tell? What if the dominant rock types on the early Earth were of a kind that simply couldn't withstand the ravages of time or contained no useful elements for dating? Our understanding would be fundamentally biased towards the history of the most durable materials. It's like trying to reconstruct the entire history of architecture by only studying buildings made of granite. You would get a very skewed and incomplete picture, missing the entire history of structures made of wood, mud brick, or ice. The very instruments we use to see into the past may be systematically blind to entire categories of what was once there. This is not a critique of the method, which is brilliant and robust. It is a humble acknowledgement of its detection limits. Our knowledge is a map, but every map has edges. And beyond the edges of this map lies a vast territory of what might have been a history for which our best instruments may have no signal to detect, lost not only to the grinding of geology but also to the inherent limitations of our own ways of knowing. Reopening the main thread of our inquiry, we can see that the question of an erased history is not just about missing rocks, but also about the potential for missing entire chapters, because we don't yet know what language they were written in or what tools are needed to read them.